Okay. Does anyone have any questions from the previous session? All good. I'll give you a quick overview of what we have covered so far, and then we'll move on to new material. All right. Okay. Share screen. Do you all see this tutorial page? Great. So in the last session, we learned how to copy files and move them. We also learned that move can be used for renaming files. So if you type move file1, file2, it will change the name of file1 into file2. We also learned how to remove files, and I warned you that there is no trash bin or recycle bin on Unix. So whatever you delete, it's gone forever. So be very careful with this rm function. And rmdir is used for deleting directories. So if you want to delete a directory, you use this. But rm is used for deleting just files. And cat is short for concatenate. We learned that we can combine two files together. Actually, I'm going to talk more about that today, but cat can be used for creating a file. And we learned about less command, which it is used when we have a big file and we want to just see one page at a time. We can use less, and less can also be used for searching a specific thing inside a big file. So it's very useful. And head shows just the top 5 lines of a file, and tail shows the bottom 5 lines. And grep is used for searching for specific keyword inside the file. And the difference between grep in this case and less is that grep just shows you the line that contains that keyword, but less can take you to that place, also showing the previous the lines prior and after that point. And WC is the word count. This is short for word count, and we'll talk about this today. I don't think we covered it last time. Also, before that, we also learned how to list the files, how to create a directory, how to change into that directory. We learned about this thing, tilde, which is a shortcut for home. So if you do cd this, it will take you to your home directory. And pwd is short for print working directory. It shows the address of where you are right now. Okay. So, all right. Okay, we can start from here. I think we covered that, and we covered that up to here. So we'll start with this command, grep. And it says, don't ask why it's called grep, because we don't know. So you can open up your terminal. You should be in your home directory. If you're not, you can just type cd that home, and it will take you to your home directory. And if you type pwd, it should show something like this. Okay, if it works, then give me a thumbs up so I can continue. Great. And here, if you type ls, you see a bunch of stuff. And there should be a folder called coding from last time. So you can type cd coding, and inside that there should be a few things. One is called backups, one is called list. Ignore this one, but there should be a file named science.txt. Do you all have it? If you don't have it, you can just do this. Cat, I love, so sorry, one more time. Cat science.txt, I love science, and Control D. So after typing this, you can just do Control D, so it saves it. So if you type ls now, you have to have a file named science.txt. Do you all have it? Okay. Diego, do you have it?
I don't think so. I guess I'll make it right now real quick.
Yeah, you just type cat, this sign greater than sign, science.txt, and then type something like I love science, and then hit Control D. How about you, Runlong? I'm not sure if Runlong is still there.
Oh, I just type in the chat as I have it.
Okay, sorry, I might miss the chat
So
because
sorry, I am in the public space. So
okay. Let me see if I can show chat so that I can see. Okay. All right, great. So
And then
let's
real
talk.
quick, Ahmed,
Yeah,
after I add the text for the file, I hit Control B.
Control D.
D. Okay.
Yeah. So Control D, it just exits out of the file and it saves the stuff that you typed into it. Okay. So now I have a file. If I type cat and the file name science.txt, it should show the content of it. And in my case, there's nothing in it. Let me fix this real quick. I can do nano science.txt. Oh, there it is. Okay. And it says I love science and cats and stuff. Okay, it shows the output down here. It's kind of weird because it's a single line. That's why it looks kind of hidden. But if this was a big file, it will output all of the content of this file. And if you're working with a big file, you shouldn't do this. You should always add a pipe more or a pipe less. So this is called pipe. On your keyboard, it should be around where the return button on Mac and where the enter button is on the Windows. So the concept of pipe is to put the output from one command into another one. So here we're piping. Have you heard of the term pipeline in bioinformatics? That's so in bioinformatics, pipeline means you create a system where the output of one program goes into another program. And it's used for automation. So instead of you just doing every command at once, you can pipe it. So from one command to another, and then it becomes automatic and it does a lot of work for you. It saves a lot of time. But here, pipe means to get the output from cat and put it into less, meaning that just take the output from cat and show one page at a time. We don't have to do it right now because this is just a single line, but if this was a big file, then we would have to do that. So I want to talk about grep. Grep is used for searching. You can type grep science, use single quotes here to search for exact matches, and then science.txt. And if you do this, it will show you the line where that file has the word science in it. And we can try with less. We can do less science.txt. And here it shows that the end of the line was reached. And if you type slash science, it finds that word for you and shows you exactly where it is. Okay so far? If you need time, that's okay, I'll wait. And to exit this, you type colon Q. So colon Q like this at the bottom, that will exit out of the file. So for grep, it's important to remember that it's case sensitive. So if I capitalize science, it won't find it. To get around that, you can type -i, and in that case it works. So -i ignores the case of the keyword that you're searching. And you see, and there are some options for example, if you don't want to see the lines that have science in it, you want to see everything but that line. And that's useful because imagine when you're working with a lot of data and your file has data from two groups, group 1 and group 2, and you just want to see group 1, then you use grep group 1. And that will only show you the data for group 1. And if you do grep-v, grep-v group 1, that will show you everything but group 1. So there are useful commands here that you could use. -i, -b, and -c only the total count of matched lines. So if I do grep -i c, it says there's one place where it found it. Okay. Speaking of counting lines, there's a very useful tool called WC, word count, that can be used for counting both the lines as well as the numbers of words in a document. So if you have a document, you want to see how many words it has, you just type WC science.txt. And so this says 0. That's kind of weird. It has 0 lines. Part of the reason is that we probably didn't hit enter at the end of the line. So there's no line break. That's why it says there are 0 lines. The second number is the number of words, 3 words, and 15 characters. So again, wc science.txt will give you that. If you just want to see the number of lines, you type wc-l, 0 lines, which is weird. To fix that problem, I can do this nano science.txt, and I go to the end of the line and hit enter. And then I save this in Control X. I say yes to this, and I don't change the name. Now, if I do wc-l science.txt, it says there are 2 lines. I don't know why that's happening. So -l is the number of lines, -w I think is the number of words. Yeah, so it says there are 3 words in it. Okay, so that's the end of this section. We're gonna start on the next section. But before we get into that, I'm happy to answer any questions or comments. Are these all easy to follow so far? Okay, great. Okay, so bioinformatics is easy, but it gets hard real fast. So I want to make sure that everyone can follow along, and feel free to let me know if there's something that needs more explanation. So you have heard me talking about cat, which is short for concatenation. It can be used for merging 2 big files or 2 small files, any files. But we're going to also learn about this, the greater than sign, which you can imagine like an arrow, meaning that the output goes into something. In this case, the output from cat goes into list 1. And if you imagine this as an arrow, the direction, the flow is from cat into list 1. And it can be used for making a file. You can type cat greater than list 1. You can call it list1.txt if you want, but also just list 1. And then it gives you an empty line for you to type stuff. So you can type like this says pear, banana, apple, pear, banana, apple. And then at the end you hit Control D. This little sign means Control key. So hit enter and Control D. Now we should have a file that is called list1. I'm going to turn on the AC real quick, just 1 second. Okay, so if you want to see what's inside list1, you just type cat list1. And it should show you all the apples that, all the fruits that you typed in. Okay. Now there's an exercise for you. And I'm going to randomly ask one person to share their screen. So we want you to create a file that has orange, plum, mango, and grapefruit in it, just like what we did with pear, banana, and apple. So I'll give you a minute to do that. Are you all set? Okay. Becca, can you show me what you did? Screen sharing.
It says that it's disabled.
Sorry, I should do that. I always forget. Okay.
I think you
Okay.
should be able to see it. I ended up having to exit out, but came back and it's there.
Okay. So this is good, except in cat list 2, there should be a greater than sign. Cat greater than.
So I did that, and so I've made the list.
Oh,
I
you did.
accidentally exited out. So I
Okay.
think it's all there.
Yes,
Yeah.
great. Yeah, thank you. Awesome. Did it work for everybody? I'm realizing that, Paul, I haven't been seeing you, sorry, so I wasn't paying attention. So are you all set with everything so far?
Everything's good.
Great. Okay. So back to share screen. When I'm on screen share mode, I only see some people, not everybody. Let me see. Oh, this was okay. I fixed that. Great. Sierra, are you all set?
She says yes in the chat.
Okay, thank you. Great. Okay, so we're gonna make another file like you guys did already. Orange cat list 2, orange plum, mango, grapefruit. Control D, save that. Now we have two lists, list 1 and list 2. Let me remove this one, list1.txt. So now we have two lists, list 1 and list 2. We have two lists of fruits, and our task is to make a big list combining the two. So what they will do is just take the lines from the first file and add the lines from the second file and make it into one file that we're going to call big list. So concatenate list 1 and list 2 and move the output into big list. So you can type it like this, and you're going to have a big list. Cat list 1, list 2, put the output in big list. Okay, and if you type ls, you should see a new file called big list, and if you type cat big list, you should have all those fruits in there. So the lines from the first file and the lines from the second file. Okay. So I told you about redirecting the output. We use the greater than sign, but in bioinformatics, you can also use the smaller than sign for having the flow of information in reverse. So we were using it to save into a file, but we can use the opposite sign, smaller than sign, for getting the output from one file into the command. and I'll explain that in a second. One useful tool that you're going to use a lot in bioinformatics is called sort. It will sort everything alphabetically. So if you type sort and dog, cat, bird, ape, dog, cat, bird, ape, and if you hit Control D, sorry, Control D. So I typed dog, cat, bird, ape, and then it gave me this alphabetically sorted list: ape, bird, cat, dog. But it only printed the output into my screen. It didn't save it anywhere. So if I want to save it into a file, I should redirect the output. So this is how. So if I want to sort, so back to big list, we have a bunch of fruit here, but we want to sort them alphabetically. So we can just do sort smaller than sign, big list. This means that all the data from big list should go inside sort.
Can I ask
So-
a quick question?
Yes, yes.
So this is probably something I should have figured out already, but if I accidentally were to type sort and then enter, so not actually give it any instructions, and I get a new line, how do I get back? How do I get back?
You can do Control D, and I think Control C should also work.
Okay. Oh, thank you.
Okay, you're released.
Yep.
Great. So sort.
Pat, just to tell you that I forgot to bring my charger and my computer
Okay,
could be turned off at any time. Sorry. I will watch
no
the
worries.
recordings later.
Okay, no worries. Yes, I'll put the recordings up after we're finished. Okay. So now we're gonna sort all of the fruit that we have in this big list. We just sort. We type sort smaller than big list, and if I type that, you see a list that is alphabetically sorted here, but it didn't save it. So it's all on my screen. So if I want to save it into a file, I can give it a name called slist, short for sorted list. So I call it slist and hit enter. And if I type ls now, I should have a new file called slist. And if I type cat slist, it shows all of the fruit and alphabetically sorted. Okay. There's another function here called who. I've never used it, but it's useful to know. Who basically is used for who's on the system right now. And I'm imagining that it's just me on my computer, so there shouldn't be anybody else. So it shows just me. But in a Unix server where multiple people are working at the same time, if you type who, it will show you the account names for everybody. And that way you can know who's using, especially if you're managing a server where somebody is using too much of the resources and if you want to kill their jobs, they just, you can find out who's using too much of the CPU and the RAM and send an email to them, say, you're using up the server. And so that's it with this section. Let's see how much time we have. Okay, we have plenty of time. I can go into another section, but I want to make sure that we can all follow. We learned how to redirect the output from file into a command. For example, sort. The big list goes into sort. One thing that probably I missed was to append. And appending in Unix is with these. So if there is a file that is called list1 on your computer and you want to add a few new lines to it, you can do that by cat greater than. So double greater than signs. With single greater than sign, you have to be very careful, because if there's a file that is called big list already on your system, this will override it and wouldn't tell you anything. So if there's an important file with the same name, you should be careful not to replace it. So let's practice appending. I want to add a few lines to my list1. My list1 has only 3 fruits in it. If I type cat greater than list1, it gives me a new line where I can type these things: peach, grape, orange. Orange. And if I hit Control P, then look at cat list1. So now my list is growing. Okay. That's how you append things into a file. I briefly mentioned piping. It's when you get the output from one thing into another. We talked about how we can concatenate 2 files. When we merge file 1 and file 2, we learned about sorting, and we learned about who's using the server right now. Any questions so far? All good? Okay, so let's talk about wildcards. So if you type ls, you'll see now you have a bunch of lists: list1, list2, slist, big list. And if you type ls list asterisk, is it asterisk or is it asterisk? I can't remember that ever. Asterisk. Let me check. Asterisk. Asterisk. It's an asterisk. Okay. I'm glad I checked that. Okay, where is my Unix? Okay, so if you type ls list asterisk, it should give you all the files that start with list. So if the name includes list and some other stuff, then it will show you list1 and list2. If these files had more numbers like list 100 or list 200, they would still show up. So asterisk just says any file with any number of characters in its name that start with list, it will pop up. The opposite of that, the other way to do this is to type ls asterisk list, and if you hit enter, it's showing big list and small list. In this case, it's searching for the files that have the word list at the end of its name. And like I said, the number of characters that come before list don't matter. If you type asterisk once, it will show you both slist and big list. This one has 3 characters before list, and this one has only 1 character before list. There's a difference between this and the question mark. So if you type ls question mark list, it will only show you S list. Question mark in this case means just one character. So any file that has only one character before list and its name will be out here. But when we type ls asterisk list, it shows us both the files. So that's the difference. And these are very useful because when you work with a lot of files, this gives you a quick way to find the files that you're interested in based on just searching the names. Like if your files have a certain date on them or a certain name, you can easily use that for finding those files. So it's talking about file name conventions. It says that you should always put .txt. If it's a text file, use these extensions to distinguish what kind of file you work with. Let's say you're working with a text file. If you're giving it a name, call it .txt, not just project, and so on. It also tells you to avoid having space in file names. Maybe for the rest of your life, ever, no matter what kind of operating system you use, Windows, Mac, whatever you do, don't leave space in the file names. That causes a huge problem. So use underscore instead. And avoid these things like and stuff. You can just type it out and or just put underscore on it. Okay. Next, we want to learn how to get help. One quick way to do this is, so if you're working with sort command, let's say, and you want to know what it does, you can just type its name. And if it's installed on the system, which should be, it should give you some information. Sorry, not in this case, but if you can type sort -- help. And this just gives you a cheat sheet of the commands. And if you're already familiar with the program, you can use sort -- help to just find the options that you can use with that command. But if you want more instruction, you can type man, which is short for manual, and then the name of the command, man space sort, and then it will, I don't know why it's doing that. Okay, so it gives you a lot of information, and you can hit any key, and it will just go down. You can use the upper arrow and lower arrow to scroll up and down and get information. You can, if you want to exit out of this, you can type Q. My experience in bioinformatics is that usually if I have a problem, if I want to find out more about the program, I use the help, sort -- help, and that gives me an idea. And if I figure it out, then I don't do anything. I sometimes search the manual. But one of my favorite websites that I'll introduce to you is called. So you can just Google any question, how to use WC in Unix. And there's a bunch of stuff. Chances are that you're going to land in a page with full of commercials and they're going to try to sell you something. But if you're lucky, this web page is going to come up, stackoverflow.com. And I feel like half of what I've learned about bioinformatics comes from this page, this website, Stack Overflow. And the beauty of it is that people write questions and someone answers and the other people get to vote. So if it works for you, you vote yes on this and the best answer comes up toward the top. If in this case, there's only one answer, but Sometimes there are hundreds of answers, and the best one, the one that gives the shortest solution and the one that works for everybody goes toward the top because people voted up. So I wanted to introduce this page. You can search anything, literally anything about bioinformatics in this page. Okay, that's how we find help. Any comments, questions? And there's also apropos keyword. I've never used it, so I don't want to recommend something that I never use. So yeah. Okay. Any questions? All right. So I can continue. There is something called background processes and foreground processes. So in Unix, you have the option to give the computer the ability to run things in the background. Just say, go do this and don't bother me. Just tell me when you're done. And that's one way. It's called background process. Foreground is when you want to micromanage things. You want to know everything that it does. And that's usually done when it's your first time running a program. You want to know everything that it does. So you do the foreground process. And after that, when you're sure that it's working and you trust it, then you just send it to the background. So one command is called sleep. If you say, it literally does what it sounds like. It makes the computer sleep for, not to shut down, but it just pauses. So it doesn't do anything. So if I type sleep for 10, that's for 10 seconds, it's not gonna do anything. You can count up to 10 and then it will stop. Why do we need to do that? This is great for making a pipeline when you anticipate that one job is going to take 1 hour, and then you want to start something else right after. So in the script that you write, you put a sleep in there. So it waits literally for the previous program to finish and then continues. That's something to know. But the reason that it's used here is for demonstration. You saw that after 10 seconds, it stopped. So when the 10 seconds is up, it just does nothing. It just waits. That was an example of a foreground process. And if I do it like this, it will just, the command prompt disappears. So I can't type anything. So I have to wait for it to finish. And when it finishes, I'm gonna be able to type things again. Right now, it finished, so I can type things. But if I don't wanna wait 10 seconds or an hour or 2 hours, I can just send this to the background. So any job, not just sleep, any job that you think is gonna take a while, you can send it to the background. And the way to do that is to add the ampersand. So if I do this now, the job will go to the background and I don't have to wait. Then I can continue writing things. And it will give me a number. It's kind of like a reservation number in a bank that's saying that the job that you just submitted is being run in the background. This is the unique ID, and that can help you find it in the future. Let's do a 20-second sleep. Now it's saying that the 10-second nap finished. Now it's doing a 20-second nap, and it has an ID. And if I type jobs, it's showing that that job is running in the background. So that helps me find it if I wanted to kill that job. If I decided that I made a mistake in that command and I don't want the computer to just go on and on running that analysis for me, I can just type kill percent sign 2. Here, the number it gives me is 2. I can just do that and it will kill. It says no such process because the 20 seconds was up before I got to kill it. But it also tells me that job number 2 was finished. Okay. We can also see what's running in the background with the bg command. Or you can just stop it with these commands, Control Z, and then you can do it in the background. I mentioned jobs. It will list the jobs that are in the background. If you want to bring something to the foreground, you can use this. And the FG will bring back the job. You have to give it the job number with percent. So %1, %2. And I talked about killing. So if you want to kill a job, you just use kill and then the number. And there's some more information here that I don't want to cover because I don't think you're going to come across. So any questions so far? If not, then we can get into some more interesting things, some more useful things. gzip in Unix is very important because, oh, sorry, I'm realizing that maybe I should end this meeting early because we have a lab meeting at 1. And so you guys are going to need to walk. So, okay, is this a good time to stop? Okay, good. I'll stop here. We'll start from gzip next time. And the next meeting will be on Friday at noon. Any questions, comments? All right, thank you,
It's
everybody.
Friday at noon.
Isn't that the normal time?
I think it's Monday.
Monday, sorry.
Okay.
Monday at noon. Thank you. On Friday, we're gonna do some lab work, so I'm gonna send out an email about that. Okay. Right. Thank you all.
You.
See
Bye.
you
Thank
soon at the lab meeting. Bye.
Yeah, it's not fun.
Thank you, Hamid.
Sure. Say bye.